Okay, it should be live. Here we go. So, welcome back. Since last time I've cleaned up the tracer stuff. So there was an issue where I realized that I used to have all the like all these messages in one class, and then I realized that there's actually like this pile of endpoints that all use the exact same protocol. So it doesn't make any sense to copy and paste it. So I needed to have it like a separate class for every endpoint. So these coprocessors have an interface that has a number of endpoints, and they're like channels, like controlling different things. And so, yeah, like originally I was thinking, there's not going to be that many for each coprocessor. Well, there is, and at that point, it makes sense to clean up the code. So I did. And then the other thing I did is I started using my memory diffing tool. I have a register monitor that is intended for like hardware registers, but it works fine on memory. And it just dumps it all the time, like every time anytime you want, and tells you if anything changed. And so I already knew like there was a block of memory for the main DCP endpoint, and then these obviously had a message, this one, that also passed a address to another block of memory. So I implemented that. And then I add those things to the tracer, and right now it's like some random ass length. I don't even know what the real length is. That's one thing I want to find out. But basically, once I did this, and once I had the thing dumping memory in IO address space, because the pages aren't mapped like contiguously, everything showed up. So I can see all the commands now. And that's what I'm going to show you right now, actually. But let's go to this. Let's put this here. So, yeah, like I can see basically every time anything writes to memory before or after, before sending a command for the host or after receiving a reply from the coprocessor. So, but it's super slow now because every single command that dumps all of the memory because why not? Because that way you can see if anything weird is happening. But that's okay, because once I figure out the protocol, then this is going to be making a lot more sense. So if I start this now, let's give it a start, and you can see stuff happening, real soon. So you can see this is the initialization, and it actually tells us what endpoint each one is, which is very convenient. And we can already seeing some like serialized data going on here already. And eventually we're going to get all the DCP stuff. So I'm actually just going to let this run until macOS boots, especially because this is like a clean console, so I can actually the scroll bar is going to be useful. And then like not touch this console, because that way I can use that as a reference, because it's always annoying when I start like interacting with it and then I can't find where it was. Another thing I did is I added ASCII dumps to my register differ, because obviously I didn't need that for real registers, but now there's strings in here. And also I added for hex dumps the little star thing for the initial dumps. It does the repeated thing, so that I don't get like megabytes of zeros on the screen. And this is all pushed, by the way. So I'm gonna pull up the screen, and this is as you can see, is super slow, but that's okay. We're gonna let it boot, because I also want to see like if any of the buffers reach the end of the buffer and like wrap, and I want to see what the lengths are. So we'll find out. It just keeps going. Like every single command is dumping all of the buffers from all the endpoints, which is obviously stupid, but I want to make sure I don't miss anything right now. And then as I figure out how the protocol works, which I can already tell is pretty simple, Of course, then won't be anywhere this slow because I only dump the parts that we need. And that's a lot of stuff. And there we go, the screen is black. I know the kernel guys are gonna hate me for having to implement a like JSON binary JSON like parser to make this all work, because that's like some of the data structures you see are basically binary JSON. It's an IOKit serializer thing. We'll talk about that later if I get to the part where I need to write a parser for that, because that's actually interesting. I didn't know what it was at first, and I worked it out from an earlier memory dump just by looking at the data, and it's pretty simple. So that will actually be a nice educational video, I guess, on how to reverse engineer a data structure, without any code. But first, I want to get the command thing done, because it doesn't make any sense to look at the data before we figure out where it is and why it's there. Should get the Apple logo soon. And we're now doing DCP commands. Like there was a thing before with like those, like there's the IOP stuff where like commands to the other endpoints, and then there's like one master endpoint that is different and uses different, completely different protocols. So I don't know why they did that. That's a lot of data there. Those look like buffer addresses or something. There's clearly a lot of complexity involved in this, and hopefully we don't have to do like everything to make it work. Hopefully, we can just run a few commands and bring up the output and not have to, there's probably a lot of extra stuff going on. We'll see. I'm kind of hoping it's not that bad, because I know iBoot needs to bring up a basic display pretty easy, so like it shouldn't have a huge amount of prerequisites, but that's kind of just a guess. So we'll find out how much stuff is really required. There will be a client for this in Mini and Python at some point, so that we can experiment with everything before writing a Linux driver. In fact, I want to get the GPU working from Mini too, like just render a triangle without Linux. If I can do that, then that means I know enough to start writing a Linux driver. Should be getting a desktop pretty soon, I think. DCP backlight, good question. I saw some references to backlight, so possibly. That's the kind of thing Apple would do, because they probably do like dynamic backlight control depending on the image and stuff like that, I bet. But that's just a guess. I know they do a lot of fancy stuff on like iPhones and like with the HDR stuff, and like that's why there's a lot of complexity here for all the like color models and all that stuff. Ah, there we go. Finally got the Apple. I told you it's slow. It's like every like block here is one frame basically. Yeah, all the True Tone stuff too. Yeah, and obviously, like supporting that on Linux is sort of a different story, right? Like, a lot of supporting this on Linux is more about less the kernel having the driver features and more like user space having useful tools, right? So the people who want like color accuracy on Linux and HDR and all that stuff, that all basically depends on things like Wayland doing it right. So like it's something we'll push for work on, but we can't magically make all that work on Linux with other people working on it. So. One second, gonna go to get some water. Almost there. You can see I got syslogs working. Like these are log messages from the DCP, so that's already decoded. The syslog protocol is pretty simple, so that's nice too, because obviously, anytime there's a syslog, that tells me about whatever just happened. So, oh, that's weird. What just happened here though? Like diff mode, and then like, huh? Well, that's kind of strange. Like my. Like, there's a /n thing. There's something weird about the syslog there, actually. But this one's fine, no? Isn't it? Yeah, this one's fine. Oh, I bet I know what happened here. There's no null terminator somehow, I bet. I need to think about that. But then why end up like... Oh, yeah, it's probably the previous data in the log then. Yeah, I must have like an issue with like the size is in a different field, and anyway, desktop when? Soon, hopefully. Oh, there we go. Yes, it's like 1 FPS. But again, that's because I'm dumping like a megabyte of data every single frame over USB, you know, plus a bunch of bits. It's like, this is slow on purpose, but that's fine. I'm gonna wait until like the blinking cursor shows up, and then stop it there. There we go. Is it blinking? Not quite. There we go. I think it's blinking now. Yeah, so now you get 1 frame for every blink of the cursor, which is what you expect. So let's stop it there. And that's a long log. I kind of want to save this with the colors, but I don't even know if I can do that in console. I don't know if you can... Oh, wait, no, isn't there an export HTML thing? That'd be pretty cool. Save as Python file? What? What does that even mean? What? What is... What? Wait, what does that even do? What? No, it's just text. Okay. I think it's just because I'm running a Python file and somehow it thinks like it uses that file name. No, HTML document. Log. Let's call this DCP boot trace.html. I might upload this somewhere later. That is slow. Oh yeah, but that's good. Ooh, the font is definitely in the right font here. Or it hates the colors or something. I think somehow the color... Oh, it must be the bold. It's the bold stuff that changes the font size. Yeah, Firefox doesn't love the amount of text on one screen here, does it? But anyway, we can worry about that later. At least it works. Wow, the rendering is not great, isn't it? Hello. I think it really... Okay, we have the file. We'll worry about showing it later. At least this scroll is faster, actually. Here, where am I? Yeah. So anyway, kind of curious about the syslogs now. What happened to that? I'll look at that in a bit. Actually, no, hold on. Where's the ASC syslog log here? Gets A0 bytes, and then just I have 128 bytes for the log, and it just stops on a 0. But I'm pretty sure the header doesn't have the length, so I'm not sure what happened there. I'm gonna do a quick dump of this syslog buff. CT, not the TBR. Yeah, this. Don't need that. Then pay whole page. I think it's 1 page for the syslog. And then this should be tracer.ep.syslog.state. I think that's it. Yes. And I don't know if I have those still, but the ones that bought had like lines on the. Here we go. Like those are fine though. Let's just get trying. But like here, what happened here? The power state F. So here we go. Yes, the parser redef mode XF. This is 0. Oh, did I not split it? Oh, that's why. Because I did R strip, but yeah, that's why. That's why. That's why. It makes sense. Okay, fix that bug. So, okay, let's look at this. So the first thing is, and this is going to make it much faster because it'll remove most of the dumps. This is more. It's just the volume and more the amount of commands sent around. So, yeah. So this is some system stuff. I don't care about their buffers for like crash dumps. But the interesting thing is the syslog starts here, then it says the shared memory for the DCP, and then it's mostly empty now. I'm not sure what that for is, but it's probably relevant. And then here's where it gets interesting. So every IO endpoint, this is 20, but I have a thing where like if it collides, it appends. So IOP is EP20, and this is 21 hex. There's a shared memory here that gets assigned here in get buff, and it's empty initially. And then as soon as it acts, and then the next message is received, there's already stuff in this area. These are pointers, and this is interesting because I just realized this is actually the like next read pointer. But I was wondering how it would work with like it was pointing to the head of the command. So like what about when there's no commands? But apparently it points to the end of the buffer minus something. And I wonder if the commands are like fixed size. So this is kind of interesting. So let's look at this. There's like 2 commands here, right? Or something. So yeah, when nothing comes back, it gets back command 8A, and there's these 2 headers, and this is like a send, this is the receive buffer, which I noticed earlier. And so now, yeah, and then it gets another command 8B, 1001, then it sends A3, then it receives an 85, and at that point, there's stuff. So A3 must be like the hello command. And then the interesting thing is it got 2 headers here. So this says 100, which starts here, and I think that's the like head of the next command. But it's kind of strange. And so then you get this 80 and 40 offset, and this is where like the pointers are stored. So what happened here, I think, is that as soon as this got that like command, it the host writes here to acknowledge that message. And then there's another so there's 85 and 86, and 85 and 86 are probably these 2 commands here. But because here it only got 80. No, but it didn't. They're different. So it's not 85 and 86. So it's like let's compare these 2, right? So this is 100. Okay, so this is 1 command. So that's a length. Is that a length? Or is that a pointer? Because it might be a length. Maybe I'm just confused. Okay, let's hold on. These might just be the headers with the total length of the block. So if we look at like some of these, there's 80, 80, and it gets that. But 100, I mean, it just might just be padding here. Hmm. Yeah, so it is, wait, what? Sorry. There's zeros here. Yeah, because this is changes only. That's why I'm a bit confused. 4120 is all zeros, and then yeah, and there's all zeros. I was counting lines, and it wasn't making sense. So so every command is like hex 80 bytes here, at least. But I'm pretty sure they're variable length. So let's see what happened. Like, are those pointers or what are those? So if we look forward to, like, here's something in 24 that's more interesting. It does the get buff. The init is the same. The things in the beginning are the same, but then it gets to 200. This is one command though. It only has one header. No, sorry, there's two commands here. So this is a length, obviously, of the command. And like 64 probably makes sense here, right? Actually, wait, there's more than one thing here. There's a 65 here. That's a different thing probably though. Hold on, 64. Maybe it's after the header. It's probably like a payload. Let's see. So these are contiguous. And this would be 80 something. Yeah, so this would be 60. And then over here, yeah, 64 starting here or something like that, right? So that makes sense. It would be this would be the header, and then the 64 64 bytes. That makes a lot of sense. And so, are they just delimited by the headers, and then this is the right pointer? But see, it's kind of strange. Or is it that this is offset? It might just be that this is offset by the header size. This will tell me that. This is 200. And it starts at C0, so it would be 2C0. Well, that makes sense. Because that's here. So with padding, that lines up. So that looks like a right pointer, all right. And then that would start at here at C0, right? So there's the little header area at the top. So that makes more sense than what I was thinking earlier. And this is just the buffer size then, which also makes sense because it adds up to 4K. So there we go. I don't know what this is. So this is basically a data structure then that we have. This is a ring buffer, and this is the right pointer. And we actually have two ring buffers in sequence, one for commands and one for responses. So we can actually make a little class for that. Yeah, this makes, yeah, so here's like one, right? And also clearly these are padded to some extent because then the actual commands have a different kind of size. So it probably pads to like, a cache line or something. Yep. This is kind of interesting though, because this looks like it's this almost looks like it's like breaking up one command into two things, like 2, 1, 2, 0, 1. Like this looks like it's splitting commands into blocks anyway, which is a little bit weird. But I guess we'll find out when I start breaking them up like that. But this is definitely the size for this anyway. So, and E8, and this is 100. So that's, I guess the padding has to be explicit in that case. Because it would be like F8 and one more. Maybe this is also okay. So maybe the data starts here. That would make sense. And in that case, Yeah, because this is actually basically contiguous except for that part. But the simple video interface, does that match? Oh, 1, a bunch of zeros. I think this is more of that serialized stuff. But let me see if I can see what the others. Make sure that it's not dropping there. These are D4. See, these are separate, but this looks like somehow a broken up command. Though it might not be. It might just be 2 commands though. So the big one, E8, D0. Is there anything larger than E8? E0, E0. Well, let's look forward. Let's look to the further down. E0. And these are all short. Oh, there's some interesting stuff here. No, that's also the big ones. Oh, E8 again. But there's only 1 command, so... and that's the other protocol. That's the DCP one. 5044 IOP. Those look pretty small. Brightness scale. That's the main thing again. Yeah, maybe they are pretty short for those buffers. IMP. Oh, there's one. It's always E8, but it always ends there, so maybe that's unrelated. 1 second. I actually need to use the toilet. Sorry about that. Yep. I don't know what DCP stands for, but if I had to guess, it would be display coprocessor or display control processor or something like that. So, yes. So basically, the pointers and stuff. So this is 64. If we say this was the header, which was that makes this hooks 8 bytes, then this needs padding. I get the feeling it's going to be implicitly padded to the buffer size. So in that case, I need to make sure I understand where that 64 comes from. So if I come from here and I count back 64 bytes, It's hold on. Oh yeah, no, that's the header. So basically, it would be here and then 4. So it has to be a 16-byte header. No way around that. This is probably like the command code or something like that. And actually, this looks like bytes because 0, 2, 05, 04, 49, 02. It looks like it writes size first, pretty much. And yeah, in that case, this is almost definitely padded to multiple of hex 80 bytes, I'm guessing. 200, 100, 200, 200. Let's just look, continue this. 780, 700. It all looks aligned to 80, doesn't it? Yep, that looks pretty much. Oh, no. There's a C0, so it's aligned to 40, which makes sense because that's more like a cache line size. So how did that happen? Probably here, right? No, before that. This was IOEP2B after this one. 44 and then an E8. And I guess it ended up unaligned after that at 40. So yeah, I'm gonna call it 40 in that case. That looks quite reasonable. 740. There's definitely no 20s going around. Yeah, C0. Yeah, so I'm gonna call it like that. Header, size, some kind of fields, and then align to 40, multiple of 40, and this is the right pointer, and the right pointer begins at I'll say it. Oh, and also this makes sense because that's why they have these so far away, because that's a cache line, right? And you definitely don't want the IO coprocessor and the main CPU to be like bouncing cache lines, even if it's cache coherent, which we don't know that the coprocessors are. It does seem to be with the main CPU at least, but they might be doing flushes on the other end. So it makes sense that they would align to a cache line size. That's why the pointers are done like that. And so, yeah, and so then this would be the size. It starts at 0, and this is the right pointer. After that, so it'd be at C0, 180. Yeah, 1Z0. That makes sense. Cool. Let's go with that. So, time to make a thing, and this might be moved to another file later, but for now, IOEP, and that needs 2 ring buffers, 1 for commands and 1 to responses. So we're going to make a separate class that we can reuse. Do I have reloadable in here? No, let's put that in there. Remind myself that if this is actually going to work with the IOVA, sets a state here, but on init, because I'm going to make sure that doesn't break with my reloading thing, so I need to keep state on this too. Let's I do have a init here, and then that the state gets added after the init, if I'm not mistaken. Yes. So in that case, I'm just gonna have the. It'd be nice if I had like a state chain thing that I could make more general, but let's not shave that yet right now. Let's do out buff and in buff. Actually, since we have TX and RX in the other code, let's call it TX and RX. And then I'll just instantiate based on that. And that, oh wait, no, but the state's gonna get replaced. That's annoying. What's the sanest way of doing this? This gets like that. You know what? Let's just make a new method here that can be like ep dot, not start, but like oh yes, start, because it's not really endpoint start. It's like endpoint. It's the same as the start function, right? So then we can just do it there, and that makes more sense. So just make it a empty. Doesn't have to do anything there. That does give it the Dart, so that's fine. And then we can add anything interesting there. And actually, that will also solve this mon thing. Just do that. I'm getting messages. This is my phone. Yeah, I'll do that later. Also, I got a call, apparently. I don't know who this is. Will you 1 second? Give me 1 second. I should call these guys. 1 second. I need to take care of something. Okay, sorry about that again. Thankfully, no biggie. Go back to that. So, yeah, this is a good idea. Get the start thing done here, do the addmon, and then do the same thing on DCP EP. Right here. And that means I can get rid of this little hack here. And then I can do the if only if we have an shmem IOVA. Just do if we don't have a buffer, we can't do anything. And we need buffs. So and init buffs, and then here when we do this, add-mon and init buffs, and the mon will go away once this works, of course. And actually, is this size mentioned anywhere? I get the feeling it isn't. I get the feeling it's hard-coded to 1 page each. Because this is the address, and there's no obvious size. Unless it's like some kind of mod thing going on, but kind of hard to say, really. And it initializes this stuff, right? Because it happens with the replies, so that sure looks like it expects 2 pages, and yeah, I don't see. I mean, of course, any of these could be some kind of multiple argument, like 4K multiple or something, but I mean, that would be complete random guesswork. So let's assume it's hard-coded now. We'll just make 2 little buffers like that. And then we need the states, though. And I need a lot of things, actually. I just pass the EP and let's call that base. And actually, the interesting thing is that I want to initialize this after this comes through, which means not on the get buff ACK, but on this thing, on 8a, because that's when the buffer is already initialized. Or maybe a B? It's hard to say. Either of these could be triggering that. But we always get 8b, don't we? There's always an 8b. There's always an 8b. See, because these are 2 replies that are contiguous, I can't know, there's a race condition here, right? Now, there's always an 8b, so let's play it safe and say it's 8b. In which case, I'm going to call it buff initialized, making the name up completely, but, let's do it. And in that case, we just do self dot need buffs here instead of calling it here. And then that's when we know that hopefully by here they should definitely be ready. And then yeah, that's the buffer size. I don't know what that is, and yeah. This is here. Let's make it There's 40. And now the question is, like for example here, right? There's here let's see, is there a difference between this one and this one? This one has one command, this one has two. So this initializes, and then there's a 8BA3, 8BA3, 8.5, nothing there. At that point, it has received stuff. And then there's an 8.6, and then again, no arguments there. So, and then it goes to the next one. So there seems to be no higher level indication of how many commands have been, how many packets, I guess, have been sent. And this header here does have a 2 there, but that's a 2 also. That's just D0. That's D0, D0. These are independent anyway. They don't look like a continuation to me. There's a 1 there, but that might be just a command ID. IOP space. Yeah, I don't see anything that would tell it how many commands to receive, which means I just have to read until the right pointer, and that's pretty much it. And this is 85, 86, 85, 86, 83, OB01 cafe, OA, 01 cafe. That's the address. The 4 that is 0902 cafe. It's all the same, isn't it? Yeah, so yeah, I just have to read until the end. That's fine. We're just going to read until the end. So on init, at this point, hopefully the Dart and everything works. So we can get the data buffer size. And that'll be 2 little Indian integers, self Dart, IO read, that's it. That should be all there is to it. Oh, this needs to be state for sure. Yeah, it's gonna get overwritten later because it says state. No, that's not gonna get over. How did I do that? No, this gets added afterwards. So this is the real state already. So, how do I? Okay, let's add a reset method. And then, actually, let's call it init, and let's do this in the init thing. And we can keep buff size, and that way I don't need to do that again when we read that. So here, when it's init buffs, that's you call init there. Let's call that create buffs, because we're doing the initialization later. That makes sense. And then we just initialize them. So at that point, yeah. And the right pointer is at 80. While right pointer doesn't equal self, that r state rptr. Do I have a line up here? I need those things. Can I just import all the utils? There's a lot of useful utils here. Let's just get everything. And the header is, in principle, 16 bytes. Is that just a counter, the thing over there? No, actually, because this is 2D and oh no, there's the last one, yeah. And then it goes to 2.4 and there's that looks like a message ID, which makes sense. Then you have commands and replies. So it's the size and message ID, and that's probably padding after that. So we need 16 bytes. And then it would be magic size, SID, and unknown. 4S. Remind myself how yielding works in Python. Real quick test. Okay, so on the first thing, it runs into the first yield and then stops. And then you have to ask for another one to get the stop iteration on that. So if I only read one, I need to make sure that once I get to the yield, we have already advanced the pointer. We don't know what the unc thing is, but let's just do a 0, and if it ever is not 0, we'll find out. That should be it, pretty much, for implementing this. Well, this is called as a read, really. And I need the max thing. So yield a thing, and then next, it's not none. So if we only want one message, we only yield one. Yeah, that makes sense. Cool. And then in that case here, we have command and ACK, right? And for example, IOEP26 gets a command here, and then it sends A2, and then I think ACK is not printed. No, it is printed. So it gets no ACK for this one. These are just commands. But eventually we're gonna get something on the 40s. Yeah, like here, right? So 24, it receives an ACK on IOEP 24, and then it has stuff. So I don't know if these are actually linked to the commands. So I'm gonna say send and resp, and that is a 5, is it? Yeah. So I'm not sure yet if that really is. These aren't set by fact. By the way, do those commands have something? No, those are. Oh wait, hold on. What's the, oh, the command does have the right pointer. That's kind of neat. A2 100. No. A2 180. Yeah. Okay. So the command does have the right pointer, but the ACK thing does not. So command is not size. It's the right pointer in that case, right? 280. Let's go way later. Yeah, it's the right pointer. So it doesn't really matter though. We can just assert that. Actually, that should definitely always be true for commands with our synchronous thing. And then on send, that will be a command of type IOEP send. On receive, it'll just be the generic thing, which let's just do an ACK, which is empty. Actually, it'll just be IOEP message. That's fine. And we're just going to print these. And then so for num data in self.txbuff.read btr equals message.ybtr rx command number foo tx, sorry. Just say tx, and then I can do chex dump data. And receive is the same thing, just rx. And in this case, we can skip the full logging. And eventually there'll be another layer nesting here for whatever these commands are, but for now this makes sense. I'm not going to do the return trues yet. Let's see if this works. So I like this log, and I don't want to pollute the screen. So I'm going to killed it here. Leave that console around and run it all again. Yes, thank you. This should be the RX buff. And no pointer in this case. So let's do that again and see if that works. And if that works, I can turn off the register monitor for this, and that'll speed things up a lot just by itself. Actually, what I'm going to do is detach this, put it here, put this here, and we can compare the previous log with the new one. Ooh, I have a thing. RPTR. Oh, that. What script? How did that happen? There's like this history shell here is weird, and like ends up. Yeah. Okay. Add mon. Same thing here, is it? No. Sorry, here, yeah, 57 add mon. Oh, where did that come from? EP state. I do need to import EP state from that. And then there's no shmem IOVA in add mon. Oh yeah, because we had that. So actually, this should be done in it. Should be done like that. This should be done here in it too. And that will take care of that. Okay, and now we have name shmem at mon. Why is oh yeah. I should do that. Okay, start. Okay, need struct. So the cool thing here is that I can actually, in principle, this should just work. Yeah, so that was the init here, and then it'll rerun the same thing. Okay, I'll read missing one argument. I read self-base. Oh yeah, that's a 0 there. Stream 0. Okay. Aha. Let's see what we just did there. Did we get anything? This is the startup. Why don't I use a linter to pick up syntax errors missing imports? I mean, would it help? I'm seeing them here anyway. I mean, Kate probably has something, but I don't know. I assume there's something, but I mean, you know, whatever. And so, okay, that didn't quite work though. Why? IUP, AC, none. Why none? Hold on. That didn't work. No, that's... Oh, it is IAP. A385. Oh, these are the starts anyway. But we aren't getting the... Actually, 82. 82 and 85. Oh, was it different for the starts? For the startups? Like the regular messages get sent with it's 8285, and then the first time around it is 85 for the it's A3 for the oh no, but A3 is just startup, so 85 should still be the reply. And for 85 Let's call at least let's call out thing startup. Or hello or something. Yeah, I should look into language servers, but I'm not going to shape that yak right now. Okay, what just happened here? So the memory thing happened, but did I get a TXRX wrong? Ah, that's why. This is TX. Okay, so hopefully we're going to get the rest once. Aha, I think we got... Okay, the magic is broken. Wait, I just sent the hello. Why? Okay, but we got something? Or is that... No, this is just the differs. Okay, let's see. Let's do... Oh, and I just realized the size, this is wrong, isn't it? Right, that's why. It will not... This needs to be plus 16 anyway. But I don't think that's what exploded this time, because it was the first message. So let's do header. And we can read that after the payload. So, whoa, what just happened here? What's that? That doesn't look right. Whoa. Self base. Duh. Okay. That did not work. But now we do have IOP. Okay, so what now? Is it 4C here? No, it should be 4S. Oh, binary. Yeah, duh. Run script. Okay, there we go. Cool. So that's... yes, so we get the dumps now. And I forgot the freaking... Oh, let's do that. I always do that. Run script. Cool. And now we get the messages. Yes. And like they're being correctly parsed. So we got RX0, RX1, hello. And this is the same thing. Let's just keep going. Yeah, so you see the two messages there and see the memory differ there. Same data. Okay, IOP setbuff ACK, yes. That's not the right thing. It's IOP send. Continue. Okay. Stuff is happening. And he looks pretty happy about all the splits and everything. Like, received some stuff there and actually saw that here. It to be receive. Oh, that's interesting. Why did it receive when did I search these around? No. Oh yeah, because it's right after that, right? So it received the previous message. Transmit 0, receive 0. It might just be a race. I mean, um, let's see about that. See if we get that happening in. A lot of stuff happened there. Interesting. So it's 0, 1, 0, 1. So maybe it's just like a toggle thing. No, there's 1, 1 here. Interesting. But there's definitely a counter at the top here, so that makes more sense. What Apple DCP, DPTX, HTTP? Which one? I've seen that before. This one? You talking about this one? This is from a previous message. I think is every time I reload, the memory monitors will print the current state initially, which is why you get a bunch of repetition. But here's where it got printed. Oh, you're saying that this didn't show up in... No, here it is. It's here. So here's... was this before or after the thing I fixed? As before. That's the one that was like offset. But I'm trying to figure out if... Yeah, like here, right? So here there's... No, it's not. It's still fine. I think that was just a race condition back there. I was going to send 2 messages, and like the Python read the pointer once, and then after that, it got received. So I'm not going to worry too much about that. Next time I do a whole run, we'll see if it breaks. But that is looking good, and I think the transmit and receives are both doing what it's supposed to do. IOP, whatever, TX1, 208. Huh? Hold on. 2OB. Sorry, yeah, it's the other way around. It's this first and then the command. TX1, 208, 208. Yeah. Yeah, I'm going to call that good. So return true, and then I can get rid of this. Run it again and continue, and now it should be faster. Not much faster though. Probably the most of the slowdown is the is this big one anyway, and a little bit faster. Yeah. So yeah, okay. So that is actually half of the story taken care of. The other half is... Ooh. Okay, that happened. Interesting. So what is that this time? Hmm. 4. Wonder what that is. Okay, so how about I just say magic size, and then just return the second half of the header together with the payload, and we'll worry about what those fields mean later when I make sense of messages. Uh, 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 uh. Yeah, we'll get rid of that. Okay, and now we have to work out this thing. So that's the other interesting protocol, is the DCP, the main channel. Let's go to the top. So the thing with the yeah, so this puts a 4. I don't know what this 4 is. There's always a 4 there for some reason at the beginning in DCP, and then it gets that. So one thing I'm looking for is the offset for the replies. And there's a syslog here saying heap size blah blah. I don't know where that comes from. But again, this might just be hard coded. Because once we start seeing those messages, which you can see after these get initialized. After this, hopefully, 2EB, 2C, 2D, management, 2D, yes, then 2E, then 24. This is the same thing as before. 26 and 7. More init stuff, probably. It's an interesting fail there. It doesn't like that command, whatever that is. And actually, that we had a name thing. So I want to start naming these by what they actually are. Run ASC endpoint. Yeah, self name or type self name lower. So basically, it would be nice just to. Wait, I need to. Yeah, it's kind of annoying, isn't it? No, I'm gonna have to subclass these eventually anyway. So let's do that. Because we got the init messages at the top anyways, so yeah. Interesting though, there's like 2 here, right? On this endpoint. On 20, it's system and power log service, I guess. And there's test service, DCP expert service, this service, and then there's more. Apple likes this expert naming convention. And then there's this stuff. DCP DPTX controller. 124. Is that the init? Yeah, it was the init. Well, this is called DPTX. And then 25. 25 is what? Nothing? 25 is apparently nothing. I didn't actually send anything. Well, okay. DCP AV SAC Epic. No, this was the previous one. DCP DP controller, DCP AV. So 25 was nothing. 26 is this. And apparently also DP. And then 28 is what? DCP MD CP29XX. Okay, I think this is more DCP. Let's call this DCP DP dev, and let's call this one DCP SAC. So DCP dev, DCP SAC, and the previous one was DPTX, maybe. Yeah, DCP DPTX, DCP dev, and we'll call this one DCP. Now, I bet that's an external chip. MC. I bet that's like an external encoder or something. Well, it's a Mac thing at least. and it has firmware apparently. So, but I bet it's the HDMI encoder. No, we don't need the DCP things in there. This is DCP anyway. That's dpdev, and dpsac, and dpdx. That makes sense. And then AV audio interface, simple video interface, and audio, both apparently. I guess we call it audio video. Okay, so let's rename these things. dpdx service, sac service, dpdev service, and we're calling this the AV service, I guess. And this was 29. That was right. This field service. Okay. To B, 2A is nothing also, apparently. I guess it's empty. Oh, maybe this is another multiplexing level. Maybe multiple services can share these channels. And so this is saying that maybe that's why this is. Maybe that's like basically like another multiplexing level. I guess we'll find out. But anyway, yeah, remote allocator. I mean, those are things. So 2B is again DPTX. Oh, it's DCP. Okay. 2A was nothing. Let's get HTTP service. 2B. And then AFK remote allocator. 2D is remote alloc. 2C is what? 2C is nothing again. Okay, well, that'll give me some nice names, hopefully. And this is all going to end up moving to proper, like, trace DCP file, because obviously this doesn't belong in a hypervisor script at this point, but... I think that's it. Yeah, I think so. That should be all of them. So let's make sure it still works. Yeah, dpdev, HTTP, yada yada, everything's happening now. The names make sense. And then let's look at the main one. So for the main one, it seems that requests are in one place and replies are in another, but it's kind of weird. So I'm going to reboot and start over again, because it'll be easier to pick out this stuff. Actually, yeah. Let's clear that. Yeah, so there we start seeing the other hex thumps are the ones with the main DCP things. So should be enough for them. So DCP EP, that's the beginning, and then nothing there until we get the first thing there. So there's a command, and the reply is at 6,000, and that's it. I think that's really all there is to it, and I bet the I know the argument is the length. That's why it says 10 here. So let's see. I think that's all there is to it, really. This is just a single big buffer that gets used for commands and replies. Did I get that right? The AV thing? Just making sure. Yeah, I think so. dpdev, dpdev, dpsac. Yeah. So yeah, I think this commands go at 0, replies go at 6k, and there may or may not be different types. So I'm gonna make a little note thing here just to make sure this all makes sense. So we got this style of command and reply, 2, unknown 2, unknown 0, and then let's see. Here's command that doesn't change anything, and it has a length 0, so that makes sense. But then this type means something special, right? If it's length 0, so there's that. And let's see. That still gets a reply though of length 10, which matches up. Type 2, so is that the same? Yes, that is the same as the previous one. And here's a command that does write, but then doesn't. That's the reply. Why is that written before the reply? Am I polling between things? Maybe I am. I must be, otherwise it wouldn't make sense. And that's probably a counter at that point because it's the same as that command. And then we have another type of command and a different reply. So we have unless the command, the sort of no command thing, is actually just the same command, which it might well be. But it's length 0 though, so that doesn't make sense. So this that command reply with 895D, and then yeah, no command, different replies. So obviously it is a separate command. And then repeated that, and it got that with a different number, which makes sense. And then it ran the same command, and it got something different though, which is interesting. I wonder why. But maybe it's just a different code, like maybe it's a status or something like that. And then it does it again, and it gets a 901D. And so after that, we get a change in the command. It still has a link. No, that's the reply, sorry. So then that's interesting. It like changes and then changes. Like changes after running the command and then changes. Maybe it's just writing in stages or something and it's confused. And that changes. 1D was the previous thing, and then it changes to 011D. Okay, so that looks like a counter, all right, and it's obviously reversed. D110, D109. But they might just be command IDs that happen to be sequential because then there's like D4 of 140 here. Yeah, I don't know what this bit there is. It's kind of interesting. But then it's completely different the next time around, so. And then this is interesting. There's more than one command here. D100, D. Okay, so we can do multiple commands, and that means there's a length here too. Is that what this 4 is? 4 words? This is very different, though. Or maybe it's not a command header, maybe it's just something else that happens to be there. Like maybe it's telling it what command to use for something, but it's not actually a header. That makes sense. Because there's no length after that I can see. These numbers kind of annoy me. 3818%. They look like some kind of memory address. And I wonder what it is. And again, there's a command 42 nothing, and then it gets a reply. So maybe that's just like receive interrupt or something like that, right? Unless I'm not logging enough and there's more. Let me do a little bit of bisection there. So right now I'm dumping this much, but that was kind of ad hoc. I made it up. So if we just do that. Okay, there is space for more. That's unmapped. Okay, it is 48, so I'm not that much. So I might be missing data here. So let's do it like that and see what happens. Yeah, this I broke it with a Control C. Let's do a reboot anyway, it's a good idea. Isn't this twice that though? Yeah. So actually it's just half and half, so I don't think it was missing anything. Ah, shit. That was the start of the console. Damn it. But it's looking like this endpoint is always polled, which makes sense because it's not a ring buffer. So the DCP can't just send the reply because it doesn't know if the host has finished reading it, which makes sense that there is that command that doesn't do anything. Because I'll just be like poll for replies. And that's slower because I'm reading more data. So let's look at that. That's a lot of stuff there. Okay, so what happened there? Okay, there's like stack padding going on there. But yeah, the reply definitely had some length going on. Again, that was a poll command. You got a bunch of crap. This is like the timing information, apparently. That's definitely a length here. And that is kind of interesting because it implies that this is the header. Which is actually the same kind of header as the IOP thing earlier. Same length too. Except for the unc thing is now like a 4cc type of thing. And it was FMO earlier. I'm also seeing FMOI. FMOI. Is there anything else? These have MT things though. Yeah, so it's not always that. I wonder about that one. It's like a toggle thing. Maybe it's an ACK. Maybe the CPU writes it when it's done. No, but then it would be before, or maybe it means not read yet. But then, or like a toggle thing again. And then it's set to 1 all the time. Then it gets set to 0 when it sends the command. That's kind of strange. I'm not sure what's going on there. Was I doing the polls though? Yeah, I'm doing the polls on everything. Sorry. So it has to be the host writing it pretty much, I think, unless there's some other out of band thing that is that like acts it. Anyway, it's probably not important, at least not right now, especially if it's only in the replies. So anyway, it gets a pile of crap here. Interesting. wonder what this is. OBSO, HDSO, IDSO. Hmm. But anyway, the format's pretty clear, isn't it? We know the length anyway, and then there's another length in the command. Let's just continue. But it looks pretty much that. Yeah, and it looks like command 42 is like pull, and that's pretty much it, isn't it? Let me look at the big log here that has some fun stuff towards the end. Yeah, it's oh, okay. So reply 42 also exists, and that's the opposite, I guess. It means there's no reply data. Unc2 is always 2. Oh, no, there's Unc3 sometimes. Wonder what that is. Because here we have 42 Unc0. Interesting. So there's something else going on there, some flag. But either way, the length is always accurate. And whoa, hold on. That's a different address, though. We were seeing 6,000, now we're seeing 4,000. What happened here? Oh, is that what the 3 is? Oh, maybe that's what it is. So that's a command at 0, but then there's something at 4,000. 2 of them, actually. Then 0 and then len 628, which is a lot. And the 628 one is this one, because that matches. And yeah, and then command 3. I bet the command is also going somewhere else for Unc3, but I'm going to have to go back to find that. I'll probably use the grep for it, actually. Thing is, I don't know what the command is right now because... Oh, I know, it's command 0, though. It's command 0, so maybe it's just pulling like a different channel. So I wonder if there's anything without len 0. Let me get more... Let me get that many frames here. Oh, I don't think we did this many frames. I'm getting there. Yeah. It really does look like command 3 is only used for len 0. Yeah, always len 0. Yep, that's all there's to it. Yeah, that's always that. So, and then it always gets the replies there. Yep, at 3. And interestingly, it got the reply at 3 here. Oh, wait. Isn't this backwards? It must be backwards. And that also explains some of this. That's why. That's why. Command 42 is not get next reply. Command 42 is acknowledge previous reply. And that's what this does then, surely. That must be the, like, red acknowledged bit or something like that. That would make sense. So that's why the unc thing is like the channel, so to speak. And it's the same as whatever the read happened. And so then there's like command 342 acknowledges channel 3. And then when it's actually sending commands, like, so that's probably then bit 4 is probably acknowledge. And so here it's doing a command, an actual command that sends a length, and 3. It sends another. So this is an acknowledge for what? This is an acknowledge for nothing, apparently. Oh, look, and here's a different address again. Oh, that's interesting. These must be like startup commands or something like that. Because it sends it to here, gets a reply. No, this is acknowledging the reply then at 0. So this is channel 0? I thought it was 2. Or is it just the lower bit? And this is interesting here. Because... So that's acking that reply then. And then there's another reply on that same channel. And something happened here. So there should be another... but there isn't. But maybe this is just some kind of other shared memory thing. That could be. I don't know if we see that again. And also there's a reply here, and then it goes off and does some other stuff before... But this might be in response to that, though. Hmm? 42? What are you talking about? This? The type 42 and... Yeah, I know. Like, that's the zero... You're talking about the full command? I'm not sure what you mean by the matching the first bit. I mean, this, yeah, I know, because this is literally just the field. You're talking about this. This is just the fields of this. Like, that is the same data. It's supposed to be. But what I'm trying to figure out is if that's a channel ID or if it's something else. It's a reply on 2. And this also suggests that it like got the command, right? Because that's the command address. DCP EP command 42. That's kind of weird. Why did that? Oh, that's the act for the previous thing. Yeah, okay. So it sends a command, again, length 0, and then it like the reply acknowledges something in the command area for some reason. Even though it's length 0. Maybe it always does that. And it got a reply on like of length 0 on 2, but then it got one on 3. Okay, let's read through from the beginning again here. So that's another weird change there. Like, why that offset now? A 40. So one thing that's going to tell me how this works is if I see exactly where it stops when it's not presenting frames. But right now it's too slow to be clear about that. So what I'm going to do is quit this. And as a test, instead of getting all of it here, let's just get 256 bytes and do every that. And that should be faster. And let's see exactly what it does. Much faster. So see, it ends in a command, so that's definitely an ACK. That's kind of what I wanted to see. And look, there's stuff at 8,000 now. Whoa. Really? A map page? Oh, because I'm not wrapping the pointer. I'm dumb. Yeah, that would happen, wouldn't it? That is dumb. Well, that's gonna break anyway. Because it's already dumb. I think we got most of what I wanted anyway. So like this stuff at 8,000 here with command. Oh, okay, so that was a reply unknown 33 at 8. This is weird. Like display width, display height, and then a single byte. Oh, is it unaligned? No. Hold on. .780 by 438. There's a 38, but that's not right. Maybe it's like physical dimensions. It's kind of weird though. And like the same command is used for DB timing mode ID. Oh no, that's a 0. It's really just a string. It's really just putting strings there, and then where's the data though? If it's getting some kind of parameter, that's so weird. Oh, but you know what? There's a page with like this might be another shared memory thing. Like when something gets updated. Something gets updated, maybe it gets that. Yeah, it's kind of weird. But anyway, let's see. Back to the mapping thing. So we got this changed 4 and 8. It's almost like this is some kind of other shared memory thing. Yeah, so like here here's an ACK for 3. Here's a command on 2. And then it gets a reply on 2. Length 3C. At 0. And then it gets an ACK of that. And something changed there for some reason. Which is weird. It's like it wasn't completely written when it read it. Okay, I'm going to not do that on the messages. And make sure to do it right here. Because I might be confusing myself. Yeah, let's do that again. Okay, let's see. That's a counter for sure. What? Did I not do the mod right? Which channel is this? I can't tell because... Not that one. This is correct, right? No, state. Huh? Hold on. EP DP def. Yeah, that's correct. Oh, hold on. Probably because it has to wrap. Yeah, of course. At the end of the buffer, it has to wrap. So it can always read a header at least. This has to be aligned. And now it's the payload failing, probably because the header is... Yeah, hold on. Yeah, that's why. It just has to wrap. Yeah, let's just do it in the main read thing. But okay, so payload IO read. Size, comma, buff size minus state rptr plus 16. Actually, just minus 16 because we already read that. We know that much is going to fill. It's going to fit. Actually, don't do it like that. That should be fine to do like that. But if block is less than size, then we append just that size minus block. That should do it, I think. Or not. State buff size. And no, it broke. Oh, an alignment thing. Oh, yeah, no, hold on. Hold on. We got the header. Read too much, obviously. Our pointer is 40. Let's just dump the whole thing. See what happened here. Okay. So you got 3F80, size 98. What's the 3FC0? 3F40. So it should end at D8. I'll round it up. It'll be F8, won't it? 100. Yeah. Yeah, 1C0. So what happened here? Actually, there's another IOP message here, though. Oh, does it? Oh, if it doesn't fit, it just skips it, doesn't it? Because there's 98 there. And there's 98, 98, 03. Oh, they're all 98, though. I'm getting the feeling, yeah, because obviously that doesn't make any sense. I'm getting the feeling that if it runs off the end of the buffer, it doesn't wrap halfway through. It just goes ahead and gives up. Two, three, 3, 2, 3. Yeah. It has to be that. Okay, fair. And so what I'm going to do is rptr. Let's first cache this here. And then just update it here. Right before the yield, when everything has worked. And then what I can do is rptr here, read that, and then make sure that's that. But if size is greater than how much space we have left, then rptr goes to 0, and we read everything again. And then that should just do the right thing. And actually, this will be aligned like that. That might work, although now it's... Yeah, now the next one's broken, which is why we had the thing in the middle there. Okay, let's just do a reboot for that one. I don't need this anymore, probably. Size. Again? What now? That. I think that's just that. Yes. Okay. See, this C8 here is the C8 here, so... I think this stuff at, like 80,000 is just some kind of global status thing. Let's see if I can find the first time that happens. 95, 77. It looks like a frame counter, really. 64 frame presented, right? It looks like a frame number, really. Oh, there we go. 6. And that also made the 1 happen there. And now this is interesting. Is this 5C? This is 4C. That's obviously length, but if that's 4C, it's like it starts here. But that doesn't make sense because if like this is clearly garbage from before, so it stops there. So this is the actual data. So this is more like the length starting here. But this is says 14, so it's like there's an extra word here. And then that gets set to 0. So it looks like the commands are actually like the data is one word short, and then when like that gets acknowledged, that gets set to 0 or something like that, as some kind of terminator, I guess. This is interesting. Here's a command on the 6. That's the same thing as always, yeah. 42. So maybe this bit in the reply is like reply buffer empty or something like that. So you get a 0 first. And then you get a 2. So see, you gotta reply here first with a 0. And then a 2 after that. So it looks like it's probably a big flags thing. And so I'm going to say it's not really like this. What we actually have here. It's not really like this, and it's not really type at that point. So this is kind of bullshit. And so then setchmem is 40. So type is more like the low bit at that point. Like the low 4 bits. Because the replies always have that, the commands always have that set. I think that makes sense. Yeah, because those always have it. Yeah. So in that case, basically what we have is 0. Type would be the low 4 bits, and then the rest is basically flags. And so, or maybe it's the channel thing. So that's acking the other channel. Unknown 2 is 3. Yeah, so I think reply type 42. So ack command is basically bit 6. And so in this case, command and reply, these are 2 in both cases. And then the top bits are kind of hmm. So then it acts that 342. It's always 42 or 2 for the type. I think that it might just be ACK in the end. So in replies, when it's 0, is when there's actual replied data. When it's 3, it's just an ACK. Oh, that's data that time around. That's when there's data in 3. Data in 0. Okay, I'm going to do something real quick here. Let's see how many unique things we have. Without the lengths, though. That's going to be a bit annoying to grab out. Okay, there we go. Ooh, what's with these? What's with these? The first time I see those. It looks like a normal reply, though. Yeah, I don't know what that is. Some flag. And that would be bit 22, I think. So we got that. There's also a type 1. What's that? That looks fun. Is that at the beginning only? Yeah, that's like the init, right? So set shemem is type 0, and then that's like the reply to set shemem, but that's basically it, isn't it? And then it already has the 40 there, so... What's the next time that happens? Oh, that's... It's just been several times, isn't it? Yeah. Okay. So the only commands are always either 202 or 242 or 342. And the commands with 202 are always the ones that have stuff. Oh, interesting. When that flag is set, it's also got a command. So I'm gonna say cmd empty for command These are really common, to be honest. I guess I just read no command. I can go in the common one, I guess. And then here, and the replies are always 0 or 3, plus that flag. Unless it's a 42. So when does this happen? Type 42, then 0? There. That's weird. That's like a no reply thing, but also not an actual act to a command. And it came right after that one with that bit set, which is interesting. Yeah, they always come right after that, don't they? Yeah, interesting. So it's always 0 or 3 when there's data. Yeah. And for commands, it's always 2 or 0 when there's data. But when 0, it's that weird flag. What's that about? Is that actually a thing? the replies with the 0. So I get the feeling that maybe one of the channels is for asynchronous events and then was for actual replies. And so this is a command, this is a reply to that command. In fact, I said always 95D? No. Hold on. No, it's different, but interesting. This is reading like in chunks or something. On 21D. So if I search for that, yeah, see? Yeah. It's gotta be that, right? Command for like here is an empty, that's a clear of the reply, like command. That's another reply thing. Hold on. Is it the first time? Yeah, so that's what I'm saying. Like I think there's I think the And so for threads is that counter thing here at 8K, right? Yeah, see, like 4K, right? So that's happens after a reply. So 3 is like an asynchronous reply. Zero is that command. 2 is a reply, and then command with 3 is an acknowledge of that. But there's also replies with 0. Which is when there's actual data. So 0 means reply with data. 2 means acknowledge. So basically okay, let's make some actual enums for this, and then we can do this the nice way. So it was done like this. Though I don't know why like these have the flag set. It's kind of strange. Maybe that command is special or something. It's kind of weird. Interesting that these are exactly the same count. Where does that show up? Is it like these are like the extended things. That's like the maximum length. Then why were there unknown 3 also? Like an async? Oh yeah. Yeah, it looks like that. 221D. But then the same thing happened before with 221D. So the same message can come in synchronously or asynchronously. And in this case, uh, it got a command 121D. No, that's still the async. Oh, these are not real commands though. So it's just pulling for more data this time. I guess it's just getting more packets out. But it must have been in response to something. Like here. 954A. Gets a reply with a bunch of stuff. And then it's empty though. That's weird. That's weird because it gets like an ACK to the command and then nothing. So it's like the command is still expecting more data and keeps pulling, I guess. Hmm. And then this is the same thing but asynchronous. And in this case, it was after a present. Yeah, so there's an async thing here, right? With 121D. Because before that, we should have ended in a reply or something. In a command, yeah, in an ACK for the reply. Oh no, there's another ACK for the asynchronous thing. That's still fine though. Ah, here we go. Command reply to, and then there's an asynchronous thing. See, the thing is, this is clearly a remote procedure call protocol at this point. Like, they're obviously marshalling like IO kick calls through to the processors, which makes sense, but yeah. Anyway, the async stuff starts here, right? Yeah, there's a random reply after some other stuff, and then this has to keep acking the replies. Anyway, so let's do it like the. Let's just do it like this. And yeah, sorry, but this has to go away. Or well, it doesn't have to go away, but so we do message name and just put the whole thing there. Dart.read. And hopefully we don't need that anymore. And I guess I am going to add that monitor though. But there's only a couple bytes there, so this is 64 bytes. 128 is fine. And then I can pull that there in the replies. Well, let's see how that works. Keep forgetting to do that. And we can return true there. Aren't we doing that already? What's 42? None. It's returning true. Why is that still... Hmm? Did I get this wrong? 11.8? No, it should be fine. Hmm? I feel like I have two tracers here or something. Where's Unk coming from? Huh, there's a 6 there. Since when? That's never been a thing so far. Huh? It could be a buffer overflow actually, because I paused it. What's going on here though? 202, 242, 302. Why is that? Oh, old stuff. That's why. There we go. And so what we're gonna do is read stuff here. Okay. Let's see if there was any of the 6 things here. Nope. I don't know what caused that. That was kind of weird. Or was it because it was the wrong... No, it shouldn't have been. I don't know. Okay, so... Why is that saying DC? Oh yeah, we don't need that anymore. That's definitely not needed now. Where is that coming from though? Oh, updated yet? Okay. And it's not message value. What I need is tag. Where'd message come from anyway? How did that happen? A bunch of paper? No. Yeah. How about I don't recurse there? And those should be strings for this to work properly. Yeah, there you go. And it will have a hex dump. Okay, so let's see about moving the cursor. Is that just present, or is it doing something else? It's just present, isn't it? Can I find the coordinates of the cursor? Looks like over there. Yeah. It looks like in the, you can see them in, ooh, another 6, huh? The hell is that about? Did it present? And then what? That doesn't look like the right address. No, that's not the right address. There's somewhere else where things are happening now. DCP tracer state no dot ep dot okay, so that's nothing there, nothing there, nothing there. Length 3C, what's going on there? No, it can't be that. Okay, what's going on? Oh, that's another buffer at 8,000. The heck is that about? Hmm. It's starting to make sense. So there's two sizes at least. Should be 4, should be 16 actually, right? 48, 12? I guess it was complete then. Oh, I bet I know what this is. Is it gonna be like an in buff, out buff kind of thing? And that's why it writes afterwards? And then I bet the replies don't have it or something. Or if they do, it's different. No, it works out. Also, this is wrong. Through 12. The replies have it at 0. And the commands have it here. And it's 0 here. Yeah, that's kind of interesting. And I bet at the act command all that changes. Maybe it has to be the act. Maybe command empty is just like the buffer. It might make sense. How about the replies earlier, though? Yeah, it's an act command with length, so it's fine. Yeah. It's not message line, it's whatever it was before. Hold on. Let's look at this part with the full lengths. Yeah, it's definitely like the in out area. What now? What's going on with those? Ah, that's going on with those. Oh, there's actually events here. Interesting. Emnits. Huh. Wait, that comes in through system. Interesting. That's another Marshall. Yeah, that's another. That's the data structure again. Cute. There's a D300 that might have something to do with that. A427. No, that's always one. Oh, that actually was kind of slow. Oh, okay, there's a fade. And that's why it's doing that now. It's still doing the fade. Huh. Okay. 29 starts doing the fade, that's why. Okay. Okay. Let's see. Figured that. What was the thing again? Yeah. Delete if it's not there. Just pop. Yeah. Tile 427. Okay, it's getting pretty late, and I think this is starting to make sense. So I'm gonna do a big commit the world thing because I don't think this can be reasonably broken up. This is mostly that, other than adding the start thing here and fixing the syslogs. I think that's all reasonable, yeah. Okay, I think that's enough for today. It's like 1 a.m. here, and I should get some sleep, so... see you tomorrow. Hopefully.